Alright, so direct variation is actually very easy version of a linear function. And the reason it's called that is they'll talk about, you know how you have an x and a y in your equation? Well, with direct variation, they'll say that y varies directly with x. So that's going to say that in other places too, but I'm going to put it right here. Y varies directly with x. That way, it's, you know, nice and up front and easy to find. But that's why it's called direct variation. The good news is, like I said, it's a pretty easy thing once you see it. It's actually an easier version of a linear function than the y equals mx plus b. And what it is, and this is kind of on the next slide, the objective is we're going to write and graph the equations of direct variation. This part is important. It says a relationship that can be represented by a function in the form y equals kx. Here's an important thing. K, I said k and then I write y. It is k. K is the same as m. Okay? The reason they use a different variable is because they're for different reasons. Alright? But I want you to have this k is the same as m, which is slope. Okay, but do you see here it's y equals kx instead of y equals mx? You know, you usually have y equals mx plus b. Since I don't say plus b, that just means the number that I'm adding is 0. So it's like your b is 0. Okay? So the important thing here is b is 0. So every time you graph one of these, they better go through the 0. You know, the origin where the x and the y-axis meet. That's where they have to cross. They can't cross on the y-axis like at a positive or a negative number. They have to cross right in the center. Okay, that's why I said these are actually easier, because you don't have to count up to your b or down to your b. You just start at the 0 and then they're not direct variation because they're not going to cross the 0. Same with the x equals. Like x equals 2, those are the ones that go up and down. You can't have one of those either because they don't vary directly. They don't have a slope at all, and k is your slope. Okay, so k is called your constant of variation. It's right here. It's the same thing as your slope. And the fact that it's constant just means it never changes. Like with slope, if you rise 2, run 3, you rise 2 and run 3 every time. Okay? A lot of times you will see the equation written like this. This is not the equation that you use, but it is they'll use to graph, but it is one that you use to solve. Do y'all see how it says y divided by x equals k? This is why they say y varies with directly with x. So if instead of x and y they use other letters, you know how they can do in math, they can use different letters. If it says a varies directly with b, that means you put a over b. Okay, so whatever order they say that in. If they say m varies directly with q, it would be m over q equals k. So sometimes this one is very useful, but it is the same thing as this one right here. So I'm just going to highlight those real quick to draw your attention to them. I think you should be able to highlight them there in your thing with the highlight tool. Alright, so we're going to do some examples now. And like I said, it's new, but it's actually pretty easy. The key part here is remembering this, that the order, if it says x varies directly with q, it's x over q. It doesn't really matter what letters they use. Okay? Questions so far? I know I haven't actually used it yet, but alright, so we got a problem here. It says, does the equation represent a direct variation? If so, find the constant of variation. So you have to put it, just like we did with the other problems last unit, you have to put it y equals before you know. Okay? So we have to get y alone. So if you look at this one, y is not alone. It's got that 7 with it being multiplied. So how do I get rid of it? And so if I divide by 7 here, I can divide by 7 here, and I've got y equals 2 over 7x. Do I have any plus or minus for b? No. So that means this is direct variation. This looks like y equals kx, doesn't it? So this is yes. And k equals what numbers with the x? 2 over 7. This is your constant of proportionality. Like I said, it's the same thing as slope, but it's used for different things, so they have another name for it. But it's the same thing. M and K mean the same thing in these equations. Okay, this one we got to solve for also to see. Before we worry about that 3 that's with the y, though, we have this plus 4x that needs to be on the other side, right? How do we move the plus over? How do you move a plus over to the other side of the equals? You can times it when we're dealing with the multiplying, but here we're dealing with adding. So how do you undo add? Subtract. Yeah. So we're going to subtract the 4x from both sides. So then we've got 3y equals negative 4x plus 8, and that's just because I'm putting it in the order we're used to, mx plus b. Now, what do we do with that 3? What do we do here? We divide. So now y's alone. We got negative 4 over 3 with the x, and then we have 8 over 3. But we have a plus something here, don't we? Remember, to be direct variation, it should just be y equals kx. So here's y equals kx, but isn't there something else? Remember, we shouldn't have a b. So this one's no. This does not represent direct variation, because that is the difference between a regular linear equation and a direct variation. All direct variations go through the 0, so b should always be 0. That means you shouldn't see a plus or minus some number. It should just be y equals something x, and that's it. But here we have y equals something x, but then we have plus something else. Questions so far? Do y'all see how we're not technically doing any new math? It's the same thing we did last unit. The only new thing is deciding if I don't have a number that's being added or subtracted here at the end, then it's direct variation. If I do, it's not.
So we put yes or no, like on all?
Well, on this question it says, does the equation represent direct variation? So we said yes it does here, no it doesn't here. But it said if it did, find the constant of variation. So if we put yes, then we also identify what k is. But I don't need to identify what k is here because there isn't a k. There's an m, but k is only used when it's direct variation. Alright. The next one says on problem 2, it says suppose y varies directly with x and y is 35 when x is 5. What direct variation equation relates x and y, and what is the value of y when x is 9? So that sounds like they're asking you a lot, but they're actually just asking you to put it in the equation like right up here, these equations. And when I told you that you're going to use this one anytime they say something varies directly with something, see how at the very first one I said y varies directly with x, and here that y is above x? That matters. So here it says y varies directly with x, so which one should be on top? Y. So it says y is 35 when x is 5. So y, remember it's y over x equals k. That's the thing it says above us. So now we're trying to do that. Y over x equals k. So what is 35 divided by 5? And yes, you can use your calculator. 35 over 5.
7.
7. So this is k. Okay. So remember, our equation is y equals kx, right? Well, they want to know what the equation is and what's the value of y when x is 9. So the equation is y equals, what did we say k was? Yeah. So this is our equation. Okay? That's the first half the answer. What direct variation equation relates x and y? That's it. Then it says, what's the value of y when x is 9? So y equals 7 and x is 9, so 7 times 9. So what does y equal? What's 7 times 9? 63. So this is the second part of your answer. Just on these, remember that y varies directly with x, and the equation for k is y over x. So whatever they say varies directly with, the first number's on top and the second number's on bottom, and that's how you get your k. And then, of course, once you have your k, you just put it in the formula y equals kx. So I know it's new, but like I said, it's really not bad once you get used to it. It's something that we still have already been using, but we're just adding like a new layer to it. But it's actually easier because we don't have to deal with the pluses and the minuses too on top of everything else. All right. We got problem 3 is a word problem here, but that's okay. It says space exploration. The weight on Mars varies, that's y, with the weight on Earth, x. The weights of the science instruments on board the Phoenix Mars lander on Earth and Mars are shown. So that little machine here, on Earth it weighs 130 pounds, but on Mars it weighs 50 pounds. Okay? It says, what is the equation that relates weight in pounds on Earth, x, and weight on Mars, y? So remember, we just said y varies directly with x. So if you look, Mars is y, right? So y over x is our k. So what's y? Like, what's the number for y? 50. And then what's x? 130. And then if you can reduce your fractions. And your calculator will usually do that for you. Here it's actually fairly easy. If you think about it, they both end in a 0. So you can just cancel the 0. But just to show you where I'm getting this from, if I do 50 divided by 130, yeah, it gives me a decimal. But if I hit enter, that's 5 over 13. But you probably could have figured that one out without a calculator because the zeros just go away. All right, so this is k, and it wants the equation. So remember, it's y equals kx is the equation. So we put in y equals, and then we put in our k, and then our x. So this is our equation. You don't have to always write this part right here. This is just me reminding us what our original equations were because it's new. You know, once you feel like you don't need that part anymore, you can leave that out and just do the work part, which is this side. Okay? That part will be up to you, and when you feel like you're ready, you can keep doing it or you don't have to. Completely up to you. Alright, so problem 4 says, well, on your slides is 4 next or the take note? Okay. Sorry, I couldn't remember if it went across or down on these since I have it printed. 4 says, for the data in the table, does y vary directly with x? If it does, write an equation for the direct variation. Remember, if it does, it's y over x equals k. Kind of like we did with the slope. When you have a table, you can just check. So here's the change in, excuse me, the change in y and the change in x, that's how we would find slope, right? But if it, here you have 6 over 4, because y over x. You also have 12 over 8, and you have 15 over 10. These should all be the same number if it's going to be direct variation. And so we just have to check. And you can use your calculator. Some of you that are really strong in fractions may not have to do this. Kayla, I need you to sit up, hon. Wake up. Kayla. You paying attention. Not sleeping. I feel you, but still got 2. Alright, so we're just checking to see if these numbers are all the same thing. Okay, so 6 over 4 says 1.5. 12 over 8 says 1.5. So that's good so far. These are the same. And then 15 divided by 10. Do you see how all of these are the same thing? And if you hit enter, it actually reduces. That's 1.5. Or you could do it like this, 1.5. It's going to give you a mixed number. But really what that is 3 over 2. Okay? And so that is our K. So our equation is, oops, sorry, that's a little too loud. I was blocking it. Y equals 3 over 2 x. The other one, they're decimals, so you got 3.2 divided by -2. You've got 2.4 divided by 1. And 1.5 divided by 4. Just to kind of make y'all think a bit, even before I type this into my calculator, are these 3 things going to be equal? Without even knowing my numbers, isn't there one thing in there that clues me in that they can't all give me the same answer? What is it?
Isn't it by negative?
Yeah. If I'm dividing a positive by negative here, and these two are positive divided by positive, there's no way I'm getting the same answer. Even if they were the same number, at least one of them would have to be a negative number. You know? So these two are not equal, and these two can't be equal because this is a big number over a smaller number. This one's a smaller number over a bigger number. So there's no way. This is a no. Because those y over x, they're not the same thing. And that's what it says to do. So it says if it did represent direct variation, we write the equation. We said this one doesn't, so we don't have to write an equation for it. Now, I said this earlier, but we haven't looked at any graphs on these notes so far. The very last slide is the only part that actually mentions the graphs. As we do more and more, we'll practice with graphing it. But we did a lot of graphing lines last unit. So just so you know, it's not going to be any different when we graph lines. The only difference is here, you know, y equals mx plus b is how we graph our lines. B 0 every time, so we should always start in the center. And so this very last part where it says concept summary, it's your last slide. It says the graph of direct variation equation y equals kx is a line with the following properties. The line passes through 0, 0. And the slope is k. So remember how I told you m and k were the same thing? They just have to cross through the 0. And so the 0 is right here. And here it says k is greater than 0. That's a positive slope, just like we did last unit. Here it says k is less than 0. That's a negative slope, just like we did last unit. But notice what they have in common is they both touch that part where the x and y axis cross, 0, 0. That's the only difference. So if you have a graph and the graph crosses like this, well, let me use a little paper clip. That was too. So your line goes like this. It's not crossing the 0, so you don't have to do any other thinking. It's a no. But if the line went like this and crossed right through 0, It's a yes, even if the line is, not very steep, or it's, very steep like this one. As long as it crosses through 0 and it's a straight line, it's direct variation. If it doesn't cross 0, that right in the middle, then it's a no. Okay? Questions?
So, like, when you mean, like, it has to be straight, like, you mean, like, this way?
Well, straight like a straight line. So this is just a sketch. I'm just drawing a sketch here. So here's my y-axis. Here's my x-axis. Here's 0. So no matter what, it has to cross that spot. Okay? So if it crosses that spot, it doesn't really matter how steep it is. So it can be, sorry, I want to actually cross that spot, and I'm not great at drawing straight lines. So it can be like this, that's direct variation. It can be like this, that's direct variation. Because they're crossing the 0. I mean, mine isn't perfect, but it doesn't matter if it's positive or negative. The slope can go downhill. Okay, so this was the y-axis here. This is the x-axis here. Every one of those is a direct variation. Sorry, I'm just making the axes a different color. They're the ones I didn't use a ruler on. As long as it crosses right there in the middle, these are all direct variations. Okay? What would not be a direct variation would be something like this. Or something like this. Because notice, they don't touch that dot in the center there. So the black lines are direct variation, the pink lines are not. They're all straight lines though. And by straight lines, I mean it's not a curve. Okay, it has to be a straight line. But the pink ones, they don't touch right here. So the pink is not direct variation, but all of the black lines are. Does that help? Any other questions? All right.